Hello everyone, welcome to the Mathematics and Math channel. Today we are going to solve another interesting infinite sum problem. Here we have infinite sum n plus 1, n plus 2 over phi to the n. Here phi we know golden ratio. Okay, at first glance, I thought about in the numerator we have n plus 1, n plus 2. So, what do you think? Well, let's see the technique that I'm going to use. So, the key point is differentiation. So here n plus 1, n plus n plus 1, n plus 2. So I'm going to take third order derivative. So third order derivative of x to the n plus 2. So if we take first derivative, we know n plus 2 times x to the n plus 1. But if we get second derivative, we have here n plus 1 times x to the n. Then third derivative, we know n times x to the n minus 1. Okay, now I'm going to take the limit. So if we take limit x approaches to 1, limit x approaches to 1, here x to the cube, x to the n plus 2 is equal to, now we know here 1, so we have n plus 1 times n plus 2. Okay, then here we have n plus 1, n plus 2. So instead of this part, now we have a limit. Okay, then if we take our question, our sum, infinite sum is equal to s, then we can rewrite s like s is equal to limit x approaches to 1, here a partial derivative, third order derivative, here x to the cube, sigma notation, infinite sum, n is equal 1 to infinity, and here x to the n plus 2, because here n plus 1, n plus 2, so we know here x to the n plus 2 over here we have p to the n. Well, now let's rearrange this one like limit x approaches to 1, now dapper cube over dapper x to the cube, here sum of n is equal 1 to infinity. Now here x to the n, here phi to the n, so we have x over phi raised to the n times here x square. Okay, then we know if we have sum n is equal 1 to infinity, s to the n is equal to s over 1 minus s when absolute value of s lower than to 1. Here we have s over 1 minus s, so we can write this one is equal to limit x approaches to 1, here derivative, the order derivative, and here now instead of this part we can write s over 1 minus s, and s is equal to x over p. So we have here x square times x over p, so here p, here 1 minus s, s we know x over p, and we know if we take common denominator here, this p get cancelled, and we have now limit x approaches to 1, third order derivative of, here we have x cube over p minus x. Okay, if we differentiate, we have 6 times p cube over here pi minus x to the 4th power, but sorry, not 5, p golden ratio, so here p minus x, but x approaches to 1, so p minus 1 to the fourth power. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you.